Hello and welcome to SudoKanard. This is another Kakuro video in English with my sublime French accent. And I'll be trying a double Kakuro, which is a variant of Kakuro I have never even attempted until now. And this puzzle was found on Grandmaster Puzzles website, and it was designed by Hatice Esra Aydemir. I hope I pronounced it somewhat not so badly. And here is the puzzle. Well, here's the grid. And you can see that there are double-sized cells. And so what I need to do, what you need to do if you decide to attempt the puzzles before I do, is to put digits into cells so that in every alignment, provided they are not interrupted by a black square, all digits should be different. But you see that this digit is common to this column and this column. So this digit is common to this column, and this row. So I think it's a bit awkward on the visual side, but I try to adapt. So on Grandmaster Puzzles, there are time standards. If you solve this under 5 minutes, then you are a Grandmaster, and I guess you already know that about yourself, and you're probably not watching this video anyway. And under 10 minutes, you are a master, and under 19 minutes, you are an expert. So my aim is always to be as close as possible to the expert timing, and I sometimes succeed and sometimes I don't. Well, anyway, my main goal is to solve the puzzle, basically, and to explain how I do this. So, well, while I was talking, I was inspecting the grid, and I noticed this 17 clue, which uses two different digits. So those have to be 8 and 9. That's the only decomposition of 17 as a sum of two different digits. And this is 9 with two digits, so this can't be a 9 because it would require a 0, and this is not a 0 Kakuro. So this is an 8, that's a 9, that's a 1. Oh, sorry. Oh, no. Oh. Well, no, this 9 is horizontal, it's not vertical, so the logic was flawed. So this is 8 or 9, this is 9 or 8, and this 9 has nothing to do with this cell. So I started in a very bad way. Now, this 4 clue is 1 plus 3. So here again, this digit has only two possibilities. This 16 clue must be 7 and 9. So this is 7 or 9. This is 9 or 7. This 35 clue uses 5 digits. And 35 with 5 digits has only the decomposition of all digits from 5 to 9. And almost all of them are suitable for this 9. Oh, but this cell is really restricted by this 13 clue, because 8 as the sum of 3 digits must be 1, 3, and 4, or 1, 2, and 5. And now only 5 and 4 are big enough for this 13 clue. So this has to be 5 or 4, but this is at least 5, so to fulfill this 9 clue, this cannot exceed 4. So this has to be a 4, and now this is a 5, and those cells must be 3 and 1. But this 12 sum can't be with 1 because this would have to be 11. So now this is a 3, that's a 9, that's a 1, so this is a 3, this is a 1. And this is a 9. This is really confusing at first, but you kind of adapt. Well, I kind of adapt anyway, for the moment. But now, this 28 clue, we already have 3 and 1, which makes a total of 4, and the 3 remaining digits must add up to 24, which can only be done with 7, 8, and 9. Oh, that's nice logic. It reminds me of diagonal Sudoku, actually. So these digits are 7 and 9 in some order, but both those cells see this cell. So this cell can't include 7 or 9 because it would remove the possibility from both cells. So this has to be an 8. And now this is 9 or 7 and is the same digit as this cell. And I guess it will be disambiguated with this. Oh, yes, this 16 clue is with 2 digits. And so it has to be 7 and 9, the same way. And this will be disambiguated with this. And yes, this can't be a 9 because those 5 cells would need to add up to 14. But the minimum with 5 cells is with 1, 2, 3, 4, 5, and it's 15. So now this must be a 7. And this resolves, this fixes the other cells. And now to complete this to 23, those have to be 1, 2, 3, 4, and 6. Now, so in this 35 clue, those have to be 7, 6, 7, or 8. 6, 7, and 8 in some order. And this big cell is also part of the 23 clue. This is 15, 16, or 17, so those have to add up to 8, 7, or 6. Well, that's not very useful for the time being. Oh, this 13 clue, those must add up to 4, so they need to be 1 and 3 in some order. This 33 has only 2 possibilities. Those are 9, 8, 7, 6, and 3. 9, 8, 7, 5, and 4. I don't see how I can choose. But I know that this is not a 9 or an 8 right now, by the same logic as how I decided on an 8 here. Now, what can be done? There are 5 cells in here. Oh, there's something around here. Yes. But is there? I know that the 4 cells on the top path here add up to 30 because I'm not taking this 5 into account. So those add up to 30 and those add up to 23. So these are worth 7 more than these. Oh, I already noticed that. So 6 and 7 would make 6. 6 and 8 would make 7. 7 and 8 would make 8. So that's not very useful actually. This 14 clue might be more useful. Because this cell can't be a 1 or a 3. Because this cell sees both cells in here. They can't be 1 or 3. And that's interesting. If this is an 8, then we need 1, 2, and 3. So this would need to be a 2, which sounds possible. And those would need to be 1 and 3. And I see no problem with that. Oh, something similar is happening here, no? With 2 common digits, the difference between the sum of those 3 cells must be, the sum of those 3 cells must be 14 more than the sum of these 2 cells. But that doesn't seem so restricted actually. Oh yes, no, or is it? I have a difference between this and this, and between this and this. Is there some math that I could do? Not sure. The difference is not in the same way. In one instance, I sum those digits, and in the other instance, I sum those digits. It's not the same. I don't think that's enough. There are 8 different digits in here. Oh, there are 6 different digits to make 22. Oh, I had missed that. That's what I have missed. And the only way to have 22 as the sum of 6 different digits is 1, 2, 3, 4, 5, 7. So now this must be a 7. Well, I should have noticed that earlier, but there's so much to process. So now, those add up to 18, so those must add up to 7. And there are 3 possible ways of having a sum of 7, so that's not so restricted. Now, those must be 1, 2, 3, 4, 5. This can't be a 5 because there's no 5 in this 23 sum. So let's write it down this way. This is at most 5. This is at most 5 as well. With a 6 here, if I make those cells minimum, it would be 6, 1, and 2, added up to 9, so this would be 5 at most. So the maximum sum with those cells would be 3, 4, and 5, which would make 12. So this is at least 7. And it can't be 7, so this is 8 or 9. I think that's correct. And I think this can't be a 1. Oh yes, it can. It can be 1, 4, 5, and 9. So this is at most 5, and it can't be 1 or 3, so it has to be 2, 4, or 7. Or 5, sorry. Now, if this is a 3, this is a 5, this is a 9, that makes 17, so this can still be a 2. This can't be a 1. And I think there has to be a 1 in one of those cells. Because, well, if this is an 8, then those must be 1, 2, and 3. If this is a 6, those must add up to 8, and 8 needs a 1. So there has to be a 1 somewhere. It can't be here, so there's a 1 here or there. And those must add up to 7. If I put a 1 in here, then I must put a 6 in here. So 1, 6, 8, 6. Well, that's a possibility. Or I put a 1 in here and I don't know what to deduce from that. What should I look? Where should I look? Oh, I had missed that. This is part of the 23 sum, so it can't be a 5, so it's at most a 4. So 3, 4, and 5 is not possible because it would need a 7, which would repeat here. I can't put a 3 in here. I can't put a 3 in here because then I would have a 1. That would make 2 of those cells add up to 4, and the other 2 cells wouldn't add up to 15. It wouldn't be enough. So there can't be a 3 in one of those. Two would be possible here. I already mentioned that. 2 wouldn't be possible in here. I think this has to be at least 4. Actually, I don't think it can be anything but a 5. If I make this a 4, then this is at most 3, so these two have a maximum sum of 5. That's 9, and this can't be a 10, so this can't be a 4. This can't be a 3 because it would make this a 1. And 2, 4, 3 would not be enough, so this has to be a 5 actually. Now these two must add up to 14. 9 plus 5 with 3 plus 2, 1 plus 4, okay. 8 plus 6. Oh, but 6 is not possible for the sum of those two cells, because 1 would require a 5 which would repeat, and 3 would require a 3 which would repeat. So this is actually a 9. And now those two digits must add up to 5, which make this a 4 or a 2. Nice. So it was worth spending some time on this sum. And it was somewhat tricky, I have to say. Now, how do we combine those into this 14? Can this be anything else than 1 or 3? Could it be a 5? 5 would go with 6, 2, and 1. And it would be... Oh, but 5... Well, this is both cells here. Yes, this cell sees both cells in here. Oh, but if I put a 2 or a 4, it just disambiguates this. They can still be 2 and 5, I think. 2, 5, which makes a 4 here. What if I put a 4 in here? So this will have to be a 6 because 4 plus 8 would be too much. This would have to be an 8. Those would need to be 1 and 2, 6 or 5 to complete to 7. That's plausible. And yes, with 6, 1 and 9 here, it would work. So that seems possible. What if I try with the 2? Now, this can't be 2 plus 5. But there are still some... Where do I put the 1? It's still... Oh! Then I can't put the 1 in here. Because 1 plus 2 would need the remaining 3 cells to add up to 25, which is not possible. So the 1 in the 14 sum would go there, so that would be a 6, an 8, a 6, making this a 5. Now 10, 21, so this now needs to be a 7. So that's possible as well. So that's a scenario. 2 here with a 7, with a 5 here and a 7 there. Is it really where I meant to look? Well, well, I don't see anything else for the moment. So 2 we need then this 5 and 7. This is to indicate that putting a 2 in here puts a 5 in here and a 7 there. Now let's have another look as the assumption that we put a 4, and that's... But actually, I think this isn't disambiguated because I didn't see anything. If I put an 8 here, so this now has to be a 2. Oh, but that's still a possibility, I think. Oh, that's what I was studying. Now I said that 1 couldn't go in here, so 1 would go in here, which would put a 6 here. So 2 can't go with an 8, 4 can't go with an 8, so actually this is the 6, this is the 8. That's something already. Now, so these 3 digits must add up to 8. Now, can this be 4 and 1? If I choose the digits this way, then 1, 6, and 2 needs a 5, and there a 2. But now those add up to 15, and I can't put a 13 in here, so that's not possible. So in any scenario, 1 can only go here. So this is a 5, this is a 6, and this... Oh, No, it breaks. What? Oh, I still haven't decided. No, what? Sorry. This is really a 6, but this digit depends on what I put in here. Now those two digits, 7, add up to 7. So that's a total of 21 here. So this has to be a 7. That's it. Yes, those digits add up to 7 because, no, yes, 7, that's 21, so that's a 7. And now, if this is a 2, then this is a 5. And if this is a 4, then that's a 3. And this works. Oof. So what should I put in this? In this cell? What should I put in this cell? Still some work to do there. And I'm well over the expert time limit. But I don't mind. Now about this 19 clue. Well, there's still no disambiguating. No. What about this 12 clue? If this is a 3, then those must add up to 9 without using the 7 or the 3. It could still be 5 and 4, or 8 and 1. If this is a 5, then I must have 1 and 6 or 3 and 4. Not that helpful. Oh, but this 23 must be important. This cell is at most 6. This cell is at most 4. Really? Yes, that's true. Now the sum of those 3 cells is at most... Oh, this can't be a 3, because then we would have a maximum sum of 13, and this would have to be at least 10. That's not possible. So now we know that this is a 5, that's a 2. And that's a 3, that's a 1. At last, some progress. And now this cell is at most 8. But let's have a look at all maximum possibilities. 6 plus 5 plus 8 plus 4 is 23. So the maximum values are the correct ones. Now this is a 1, this is an 8, and it disambiguates this 9-8 pair. Progress. 1 and 2, we need 3, 4, and 6 in those cells. But 6 is not a possibility in this 22 sum. I wrote it here. So this cell is, this digit is a 3. 3 is removed from those cells, and those 2 cells must be 1 and 2. But 2 can't go here because it would require another 5 here, which would repeat. So that's a 1, that's a 2, and that's a 6, which make this a 4 and this a 6. Now, this part of the puzzle is fully solved. Now this is a 5. And in this column, the only remaining digits are 1, 3, and 5. Only 1 and 3 fit in here. and only 3 and 5 fit in this 33 sum. Now I need to put an 8 somewhere and a 7. This cell is part of the 5 sum. This cell is in the 5 and in the 23, in the 33. So it has to be at most 4, and it must be 3 or 4. So the only possibility is that this is a 4, this is a 1, and now 4 comes with a 5, not with a 3, so that's a 5. And now we need to complete with 8 and 7. 8 is here, 7 is here. And that finishes this so. Well, it was kind of tricky, and I may have overcomplicated these steps. Not sure. I might have missed something. But on the whole, I managed to do it with, some exploration. That was almost bifurcation, but I don't think it should be called that. It was just some tricky logic. Well, there are other double Kakuros on Grandmaster Puzzles, and I think I'll try some of them in subsequent videos. Thanks for watching this video, and see you soon on SudoKanard.